friends, my name is Tutor. I'm a BTech graduate and today I'll be teaching you surface area volume. Firstly, I'll start with introduction. I'll give you some figures here and I'll also write a formula on that, and I'll also tell you how those formula have been derived. Okay, let's begin. Well, this is cube. You know it, right? You learned this in and well, the three edges are drawn in dotted lines. That is because these are hidden edges. We can't see through the naked eye, and these edges are not in dark or continuous edges. Now, if I assume this length as A, the rest of the edges length will also be A, because it's a property of a cube that all the edges will be of equal length. So therefore, if I write volume of a cube is equal to, right, area of cross section multiplied by the height or the length. Alright, area of cross section is, you can take any of the areas, any of the 6 faces. How many faces? 1, 2, 3, 4, 5, 6. That is front, back, top, bottom, right, left. Okay. So area of cross section is equal to, if I take front face area, A into A. So A into A into the length is again A. So therefore this is A cube. Cubic units. That is cubic units. Well, in my experience, I've been across students where they don't understand what this is. It stands for units. It's like measure. It could be in meter cube or centimeter cube, or could be also liter, etc. But when I write cubic, it just means that some unit, right? Some unit is raised to power 3. Alright. And this is all regarding a cube. Well, again, there's difference between cube and cuboid. In cuboid, we don't have all the lengths of the edges equal. If any of the length of one edge differs, then it becomes cuboid. That's the difference. That's the basic difference between cube and a cuboid. I'll draw cuboid now. I hope you understood this. This is really stuff. Cuboid. Let's say this edge has length L, this breadth has length B, and this has height H. This is a cuboid. I have indicated this edge length as L, this edge length as B, and this edge length as H. It basically means that length, breadth, and height, which when I multiply all these 3 edges length, I get volume. So volume is equal to length, breadth, and height. Alright. Now I'm also going to explain you how we get the formula for surface area of the cuboid. Surface area. Okay, when I say surface area, it means that any surface that you can see through the naked eye. Let's say this is duster, right? This is a cuboid, almost cuboid, not exactly cuboid, but this is a cuboid having 6 faces. Just you can imagine 1, 2, 3, 4, 5, 6. 6 faces, and this forms cuboid. So I can see any face, just tilting it at certain angles. I'm seeing the front face from my point of view. I'm seeing the front face now, right? Similarly, back, if I just tilt it like this, I can see the back face. Right, so that is surface area. Surface area is equal to, now, how many faces? 6 faces. 1, 2, 3, 4, 5, 6. Alright. So surface area is equal to length into breadth, top and bottom. Bottom area will also be the bottom surface area will also be equal to length into breadth. So this is L into breadth, right? Then if I take right and left faces, I'll have B into H plus B into H plus B into H. Why 2 times? Because there are 2 faces. Alright guys, so third face we are dealing with here is H and L. L and H. L into H, right? So L H plus L H, right? Alright guys, now coming back to cuboid again here. This H is indicated by the length L, this H by B breadth, and this as height H. This is a 3-dimensional figure. Now I'll write the formula for total surface area of the cuboid. Total surface area, okay. How many surfaces are there here or faces are there here? 1, 2, 3, 4, 5, 6. That is, once again, top and bottom, right and left, and then front and back. Alright. So let's write the areas of all the 6 faces and add them up and see what we get here. So I'm writing starting from top and bottom. Okay. Top is area of the top face is length into breadth. So length into breadth plus length into breadth. Okay. Instead of writing 2 times each area, I'll just multiply it by 2. Alright. Hope you understand it. This is 2 into L into B plus, again, top and bottom is over, then it's your right? It's right and left faces. Now area of the right and left faces will be 2 times this dimension multiplied upon this dimension. This dimension again be equal to B because the top face is rectangle, so opposite faces are equal. So H multiplied by B multiplied by 2. So 2 into H into B plus, alright. So top and bottom is over, right and left is over, and front and back. The area of the front and back faces will be 2 into this dimension multiplied by this dimension. Well, this dimension is H and this dimension is L. So that will be 2 into H into L. Alright. So if I take 2 common out, I'm left with L into B plus B into H plus H into L. Well, that's the formula how we get for the total surface area of the cuboid. Now volume. Volume is nothing but area of the cross section multiplied by the thickness of the figure. Now here you can take any of the areas. I can take this area and multiply by the thickness. The figure is area of the cross section multiplied by the thickness of the object or the length. I can take any area of any one of the faces. I can take area of this face and multiply by the rest of the dimension. When I say remaining rest of the dimension means that is remaining dimension. What I am leaving here is I am leaving L. So I multiply BH with L. Why? Because area of this face is B into H. That is B multiplied by H and the remaining is L. So therefore I'll just directly write away straight here. L B H. That's the volume of the cuboid. Alright. Now again, next figure is cylinder. This is actually right angle cylinder. Why do we call it right angle? Because cylinders can also be like this. You see. Well, now it is for you to observe now that this cylinder is not at right angles because it is not making an angle 90 degree with the height of the this axis of the cylinder. Here you have 90 degree, therefore it's called right angle cylinder, and this is not right angle cylinder. Alright, so let's understand how we get the curved surface area of the cylinder. Okay, imagine that I am cutting this cylinder at right here at this section. I am rubbing this portion so that You imagine that I am cutting across this face. When I cut it and open it out, right, it will appear something like this. Absolutely, that is sheet, alright, sheet of a paper. Now you see, when I cut open from here, what am I doing here? I'm actually just trying to get the dimension of the this edge or this curve or this contour and this length. I already know this is an edge, so I'll write edge. So what is circumference of a circle? See, this top surface or top face is circle. So I'll write circumference of the circle, which is 2 pi r. Right? 2 pi r. That is, you know why. Alright. Because circumference gives me length of the curved thing, like this. If this is circle, the length of the whole ring is 2 pi r. That is circumference. Circumference. Now just multiply that, you get curved surface area, 2 pi r h. 2 pi r h. Alright. Now total surface area, this is pretty simple. This comes from this formula. Total surface area, see, in the previous formula when we derived this, we left out this portion because we just assumed that there was no closing on the top and the bottom. They were open ends. But when we have a closed cylinder, you have to add the surface area of the top and the bottom. So surface of the top is pi r square, so will be the surface area of the bottom. So that is therefore 2 pi r h plus pi r square plus pi r square, 2 pi r square. Alright? Or if I take out the common terms out, 2 pi r, what remains within the bracket will be h plus r. Now let's derive the volume. This is again very pretty simple. Okay, here it goes. Volume is, as I told before, area of the cross-sectional area multiplied by the height. You got to understand what this cross-sectional area means. When I cut at any portion of an object, I should get the same figure each and every time, like this. When I cut along this, like this, I get a circle, right? You do this at home, you get it. If I cut along this line, this section, or this dotted line, I get a circle. If I cut along this line, again I get a circle. So that is cross-section area. Alright, it need not have to be along one axis or along only one direction. It could also exist along multiple directions. Now see, for this object, this could be the cross-sectional area, or even this could be the cross-sectional area. If this is the original object, this could also be cross-sectional area. That is because when I cut this object along along this direction anywhere, I get same figure, the same area, that is rectangular thing. Okay. So volume is nothing but area of cross section multiplied by the thickness or the height of the object. So which is, see, this is circle, so that area will be, that is pi r square, area of the circle multiplied by the height of the object. Back to cone again. L is slant length of the cone. Slant is, in English, it means that something which is sloping, either upwards or downward. It could be anywhere. Okay. Now this length is resting on, you can see, imaginary line, that is axis of the cone. That is length L. That is slant length of the cone. Height of the cone is indicated by h, and radius of the base is r, which is of the circular form. So now, according to the Pythagoras theorem, L is square root of h square plus r square. I'll just write it here. L is root of h square plus r square. Right? Hypotenuse square is equal to perpendicular square plus base square. When you remove that square, these two terms come under the root. Alright. Now let's discuss curved surface area of the cone. Curved surface area of the cone, just like I explained in case of cylinder, we just cut the, now when I'm explaining this, it's not going to be easy to indicate on the board, so I'll straight away write here pi r l, curved surface area. And the total surface area is, it comes from curved surface area, but in addition to the curved surface area, we add the base or the bottom. In previous case, we imagined that there was no surface supporting this upper figure. We just assumed that it was hollow, or rather it was just like a cap. Alright, so TSA is equal to pi RL plus area of the base is pi r square. If I take out common terms, pi r out, I'll get pi r into L plus R within the bracket. Volume. Volume of the, like, these figures is not easy to derive because this is not a uniform figure, right? What I mean by that is, volume is given by area of cross section multiplied by the length of the object, right? But here, when I take area of the cross section along this line, right, which also means that area of cross section along any line parallel to this line should give me the same area of cross section, but which we don't get, because here if I take area of cross section along this line parallel to this, it's not uniform. These two areas of cross section are different, right? So we require higher mathematics to derive the volume of the cone. I'll just straight away write here, volume of the cone is 1 by 3 pi r square multiplied by h. Okay. Hemisphere. Again sphere. Again, sphere is a three-dimensional object. It's not easy to represent on the board. Actually this is circle, right? But it's as good as a ball is placed here and the outer edge is drawn, right? Its radius is indicated by r. Curved surface area of the sphere is given by 4 pi r square. 4 pi r square. Volume of the sphere is given by 4 by 3 pi r cube. Again, this is, just remember all the time that area is measured in terms of square units and this is cubic units. Volume is measured in cubic units. Hemisphere. Sphere, hemisphere. Look at this word hemi, which gives me the meaning of like half of the sphere is hemi. But at the same time, when I say that, shouldn't be semicircle, be hemisphere. Alright, back to hemisphere. We are dealing with curved surface area, right? Curved surface area is given by half of the curved surface area of the sphere. Half of 4 pi r square is 2 pi r square. Well, we have an additional parameter to total surface area, right? Just like mentioned in the previous figure, we have to add the base or the bottom area, which is curved surface area plus bottom area. 2 pi r square plus bottom surface or the bottom face is in the form of circle, which area will be pi r square. So this is equal to 3 pi r square. I'm sorry. This is 3 pi r square. Now volume is again half of the volume of the sphere. Half of, well, this is directly, right? If I write half here, 4 will cancel out with 2 and give 2 in the numerator. 2 upon 3 pi r cube.
Choose the right kindergarten, a right bag, and matching bottle to go with. The right school, the right friends. Choose the right subjects and score well. Be an expert in all. The right teacher, and make sure that they like you. Choose the right timing, the right bus, and take a cab if getting late. The right train, and don't stand near the gates. Mind the pockets. Better get into ladies' compartment. Make sure your mustache hasn't started coming. Choose the right study time and forget games. IPL, IHL, rock and metal, guitar, X. The right group and be a model to your brother. Seriously. Choose the right syllabus, the right test paper. Keep guessing questions for exams. Choose the right branch, the right college, the right stream. Choose the right career. Lucky to have a father's business to take care of and a father to allow that. The right counselor, the right form, and make sure the project is submitted on time. Choose the right website and rely on your friends for more information. Oblivious of the sites they have been to, there is no end to your woes. Getting better with every step you climb up the ladder. The summer vacation shorter, the bucket list bigger, the night darker, the books heavier. The only light you have is your friends ahead of you. Probably he is right. Ever thought how he got the direction? No more spending your energy and money on coaching classes. No more missing classes for rain, rally, and nonsense. Get your interest back in subjects through our creative ways of teaching. Doubts, concepts, applications, all explained through one vibrant animation. Subjects covered by multiple teachers with repeat telecasts. Special programs only for basic foundation and paper analysis. Personality development, career counseling, admissions, hobbies, all covered. A new approach to study with long-term perspective. So sit back comfortably in your homes and watch Study Spectrum TV channel.
I've drawn a figure here and we are going to solve a problem on this figure. The question here is, I want to paint this toy, and the amount or the quantity of the paint that is required to paint this whole toy or the top, right? The toy's top, this toy's top. We have to find out that, right? For which we need to know curved surface area of the two figures. See, this is combination of two solids. The top is hemisphere, and the bottom is cone. I'll just write it. Okay. Alright, this is hemisphere and the cone. Curved surface area of the hemisphere plus curved surface area of the cone gives me the surface area, the total surface area of the toy that needs to be painted. Curved surface area of hemisphere, right? It's understood that it's hemisphere is equal to, I know the curved surface area of the sphere which is 4 pi r square. Half of it will give me curved surface area of the hemisphere, which is 2 pi r square. Right? Half of 4 pi square is 2 pi square. Curved surface area of the bottom figure or the bottom portion is cone. Cone pi r L. This formula I have discussed already. Okay. But we do not know L here, right? Now, before that, before we go any further, addition of these two, right? Curved surface of the hemisphere plus curved surface area of the cone will give me total surface area of the toy that is to be painted, right? Total surface area to be painted. Just add those two and you'll get total surface area. 2 pi r square plus 5 r L. Right? So if I take out 2 pi r common, what remains within the bracket is r plus L. R plus L. I've added this 2 and taken out 2 pi r common, r plus L remains within the bracket. Well, before we go any further and find out, right, before we substitute the value of r, we do not have L here, but we have height of the toy, but we require slant length of the cone, which we don't have. We have to calculate it. Let's calculate it. Okay. L is equal to root of h square plus r square. H is the height of the cone. You cannot take phi, you cannot, because this height includes height of the hemisphere also. We have to exclude the height of the hemisphere. So which is 5 minus 3.5 gives me height of the cone. Alright, height of the cone. Right. Alright. Height of the hemisphere is 3.5 by 2 because this distance will be equal to this distance because it's radius. Alright. So therefore this distance will be equal to 3.5 by 2. 3.5 divided by 2. 5 minus 3.5 by 2 will give me this length. That is height of the cone. Well, let's derive it. Root of height is 5. Okay, just take this 5 minus 7 by 3.5 by 2 square plus r square. Radius of the this thing is 3.5 by 2 whole square root. Alright. 3.5 can be written as 7 upon 2. Now we have 2 in the denominator of 2 is under 3.5, so therefore multiply by 2. 7 by 4. Right. If you divide that 7 upon 4 like this by usual method, 4 and 4 remained 3. 0.0, 7 the 28. Everybody knows this, right? Okay. 2 again 0, 5 the 20. So we have 1.75. Then we divide 7 by 4. So this is 1.75. So this is 5 minus 1.75 whole square plus, as we have done previously, 3.5 by 2, which will be equal to 7 by 4. Again 1.75 whole square under root. Right? 5 minus 1.75 is 3.25. That is, just add 0.25 to this number, you get 2. Right? 1.75 plus 0.25 is 2. So that is 0.25 plus 3 will give me this thing, 5 minus 1.75. So you have 3.25 square plus 1.75 square. Right? Now 3.25 square plus 1.75 square, we have to multiply and find out what the values will turn out to be. I'll just erase this. Now we will solve questions from the exercise 13.1. I'll paraphrase the question for you. Two cubes of similar size are joined, right? Joined, and the volume of each of the cube is given as 64 centimeter cube. The question asked is, find out the resulting surface area of the cube. That is, when you join the two cubes, what is the resulting surface area? What is it? Okay, let's find out that. I know that volume of the cube is given by a cube. If I indicate a as the length of the edge, a cube is given as 64. Be it first cube or the second cube. Let's just first or second cube. Right. A cube is equal to 64, or a cube is also equal to, this can be written as 4 cube. If you ask how, this is how. 64, you just factorize. 4 16s are 64, 4 4s are 16, 4 1s are 4. Now 64 can be written as 4 cube. When I take cubed root on the both sides, I get A is equal to 4. Alright? So A is equal to 4 is the side length of each cube. Side length of each cube. Or edge. Okay, I won't write that. You understood it. And I'll just tell you what is the resulting surface area here. I'll show you the faces, resulting surfaces here. Just color this. This surface, you have to find out surface area of this. Surface area. No, you have to imagine the bottom face, okay? You can't show it. This face, and then this face. In short, find out the surface area of this, multiply that by 2, add with, similarly you go ahead and do this, do for the remaining faces. Let's solve now. Okay. Okay, sure. So this is 4, right? This is 4, length is 4, length is 4. The total length is 8. And this length or the height of the cube or the cuboid, now it's cuboid, right? So cuboid height of the cube is still 4, it doesn't change. So surface area is 8 into 4, 32. Pink and right according to the colors. Surface area of the pink region. Right? It's understood that the pink indicates surface area of the pink region. 8 into 4, right? Surface area of the surface area of the front face. 8 into 4, 32. Since there are two such faces, you multiply with 2. 64. Centimeter square or meter square, let's not get concerned with that. Surely it's in centimeters. So anyway, it's alright. If I take the side face or the right face according to your side, I have this as 4. Height hasn't changed yet. Height has not changed, and this edge is also not changed, right? So I'll indicate that with green. The surface area of the green face is 4 into 4. Since there are two such faces, you will have 4 into 4, which is equal to 16. Then multiply that by 2. Finding out the resulting surface area of the cuboid, which was formed by joining two cubes given to us. Surface area of the blue region is given by dimension of this dimension multiplied by this. Top and bottom, there are two faces, so multiply that product by 2. So therefore 8 multiplied by 4. How 8? This dimension is parallel to this dimension. These two are parallel and equal. So 8 will be, this will be 8 and this also will be 8. So and this is obviously 4. 8 into 4 multiplied by 2. Why 2? Because there are two such faces, top and bottom face. So we are finding out the resulting surface area. So this is equal to 8 into 4, 32, multiplied by 2, 64. But we are supposed to add all these areas, surface areas. These are all surface areas in terms of centimeters square. We are supposed to add this. Let's add. When we add, we'll get resulting surface area and the problem is solved. So 64 plus 32 plus 64. This is resulting surface area. SA, it's understood that it's surface area, resulting surface area, equal to 64 plus 64, 128. 128 plus 32, which is, I'll tell you a shortcut method to how to add these two numbers. Okay. Consider 120 from this 128 and 30 from here. It's easy to add zeros always. So 120 plus 30 is 150. Rest is 8 and 2. The remaining is 8 and 2. Add them separately. So initially we had 150 and this 10. This is 160. Send into square. That's the answer. I have taken question number 6 from exercise 13.1. Given here is a medicine capsule. It looks like as if it is attached, the cylinder. This cylinder is attached with two hemispheres at the end. And we are asked to find out the surface area of the combined object. We have to assume that this object is attached by two hemispheres in a single cylinder. When we know the surface areas of we already know the surface area of hemispheres and cylinder. Just add them all up and you get the surface area of the total object. Total surface area of the object. Let's solve now. If you figure out the dimension of, or rather the length of the cylinder and the radius of the sphere, if you figure out the length of the cylinder and the radius of the diameter, or radius of the sphere, radius of the sphere, diameter of the hemisphere is given 5 mm. So therefore radius will be 5.2, 2.5 mm. I'll just write like this. Mm. Right? It's understood that this dimension is 2.5 mm. Half of this length is 2.5 mm. Now, similarly, this is also the radius of the hemisphere. This length is also the radius of the hemisphere. Radius of the hemisphere, which is 2.5 centimeter, 2.5 mm. 2.5 here on the right hand side and 2.5 on left hand. You subtract from 14, you get the length of the cylinder. Subtract these two dimensions. You get length of the cylinder. This length is 9 mm. That is because this is 2.5. And similarly, you have this also as 2.5 in terms of mm. 2.5 plus 2.5, 5. Subtract from 14 gives me 9. Now, surface area of hemisphere, HS stands for hemisphere here, plus surface area of hemisphere. Instead of writing surface area of hemisphere plus surface area of hemisphere, I can just multiply by 2 because the dimensions of both the hemispheres are same. The radius of this hemisphere and radius of this hemisphere is same. So I did not worry about writing it separately. I can just write it as 2 times surface area of hemisphere plus surface area of cylinder. That gives me TSA, total surface area of the capsule. Let's write the formula now. 2 into TSA equal to 2 into surface area of hemisphere. I know surface area of sphere, which is 4 pi r square. Half of 4 pi r square is 2 pi r square. Just write it here, 2 pi r square plus surface area of the cylinder. What is surface area of the cylinder? 2 pi into r into h. That is surface area of the cylinder. 2 pi r into h. If I take out 2 pi r term out, what remains within the bracket is, see here there is 2 underlying terms remain within the bracket, 2 and 1 r from here, because I am just taking 1 r out, 1 r out and 1 r remains. So 2 r plus h. So therefore, see, when I multiply this term with individual 2r and h, I still get 2 into 2, that is 4 pi r square, that is 2 into 4 pi r square plus 2 into pi into rh, that is 2 into pi into r into h, right? Multiply. So now this is equal to 2 into pi into r into, in the bracket, 2 into r. Remember, R is radius of cylinder as well as hemisphere. R is 2.5. 2 into 2.5 plus h. But here h is height of the cylinder. Height of the cylinder is 9. It's understood, right? So 2 into pi into r into 2 into 2.5. I'll just put this in brackets so that you understand it. 2 into 2.5 is 5. 5 plus 9, 14. Which is equal to 2 into pi. Again, r is radius of cylinder as well as hemisphere. R is 2.5. I can write r this r as 5 upon 2 if I'm not wrong, because 5 by 2 is still 2.5. This is multiplied by 14. This is equal to, but 2 into pi. Pi is equal to 22 upon 7 or 3.14. 2 into, I am interested in writing 22 upon 7. That is because when I write that, you shall see why I am writing that. 22 upon 7 into 5 upon 2 into 14. Why did I take 22 upon 7? That is because 7 into 2 is 14, which will cancel out with the numerator term 14. So this and this term are out. So this is equal to 2 into 22 into 5, which is equal to, now smart thing to do here is bring in as many zeros as you can when you see 5. So multiply these two first. 2 into 5 is 10. 22 into 10. Now this is equal to 220 square. 220 square. That's the answer. That is the total surface area of the capsule. Coming to the next question, I have chosen 9th question from exercise 13.1. This is wooden article. In this wooden article, there are two regions that are scooped out, or that means carved out, just removed from the whole section. Earlier it was a cylinder, wholly complete cylinder, but hemispheres are being carved out or removed from that section. Now what we are supposed to find here again is we have to find out the surface area of this object. Now mind you, this is not the object that is present, it's actually empty space because it is removed out. Alright. Now what's given here is height of the cylinder is 10 centimeters, base radius of the hemisphere is 3.5 centimeters, and we have to find total surface area. Total surface area is equal to sum of the surface area of the cylinder plus surface area of this region. Surface area of this region, because this is not present, alright, and surface area of this region gives me total surface area. Well, let's figure it out now. Alright, let's just write formula. Total surface area equal to surface area of cylinder plus, are the dimensions changing? No, right? So this plus this, surface area of the hemisphere plus surface area of this hemisphere, which is twice. So twice the SA of, that is surface area of HS, gives me TSA, total surface area of the wooden article. Surface area of the cylinder is given by 2 into pi into r into h plus 2 into surface area of hemisphere. I know surface area of sphere 4 pi r square, which is 4 pi r square, and divided by 2, that will get you surface area of hemisphere. 4 pi r square upon 2 is 2 pi r square. So just write it out here, 2 pi r square. It's always better to take up the common terms out. So which is equal to 2 into pi into r. If I take out r, this term common, what remains within the bracket is h here in this term, and what remains within this bracket is this 2 remains, and 1 r from r square remains within the bracket. So that when I multiply this term, I will get back the same equation. I'll get back this equation from this equation. 2 pi r into h, 2 pi r h, 2 pi r into r, 2 into, that is 2r, right? Because there is 2 also left out. This 2 is left out. So 2 into 2, 4 pi r square. 4 pi r square. Understood, right? Okay. Let's substitute and get the answer for the total surface area. 2 pi into r is 3.5. I can also write 3.5 as 7 upon 2. 7 upon 2. Note, just here, note 3.5 is equal to 7 upon 2. Two pi into r I substituted, and h, height of the cylinder is 10 centimeter plus 2 into r is 3.5 centimeters. 3.5 centimeters. I should have substituted 7 by 2, right? This 2 will be cancelled with 7, that denominator 2. 7 upon 2, because 3.5 is as good as 7 upon 2. Cancel this 2, 2. This is equal to, this 2 will cancel with denominator 2. Pi into 7 multiplied by 17. 10 plus 7, 17. This is equal to, okay, 22 upon 7. Why am I writing 22 upon 7? When I write 7, this 7 goes out with this, right? So 22 upon 7 into 7 multiplied by 17. 7 cancels with this 7. 22 multiplied by 17 is what remains, right? Okay. I would not recommend you doing this. What? This. 22 into 17, 7 into 2, 14, carry 1, 7 into 2, 14 plus 1, 15, right? That's what you do usually. 22, and then you add, which turns, this addition turns out to be 374. I wouldn't recommend that. This is what you're gonna do to save time. Multiply 17, this 2 digit 17 with 2. What you get? 34. Write the units digit first and take 3 as carry forward. Now again multiply 17 with 2, which is 34, and add that 3 there. That is 370. I'll repeat again. 17 into 2 is 34. So 4 here, carry forward is 3. Again 17, what you're actually doing is you are multiplying 17 individually. First you are multiplying 17 with 2 and taking the carry forward, and again you are multiplying the 17 with 2, and whatever the result is, you are going to add that result with this carry forward. So once again I'll explain this in short and crisp manner. We were given a wooden article and there were 2 regions scooped out of it, and we were supposed to find out the surface area of the wooden article. And what's given here is that the height and the base radius of the cylinder are given here. And what we did is we wrote the formula here. TSA, that is total surface area, is equal to surface area of the cylinder plus surface area of the hemisphere. These 2 hemispheres. Since these are 2 similar hemispheres, it's alright to just multiply 2 and take just 1 hemisphere. That is 2 times surface area of 1 hemisphere. Now, we have just written the formula here and then did some simplifications, and we have done the calculations to get 374 centimeters square as the surface area of this object.